Congratulations! You've completed the introduction to the V-Block System 320 and the V-Block System 340. In this section, you learned about the V-Block System 320 and V-Block System 340 capabilities relative to the other V-Block system platforms. You also learned about their typical use cases, as well as their standard configurations. You learned about the V-Block System 320 and the V-Block System 340 basic compute, storage, networking, and virtualization technologies. And finally, you learned about the V-Block System 320 and the V-Block System 340 management technologies. There is one last platform to learn about in this training, so let's move on to the introduction to the V-Block System 720. Welcome to the next section of the V-Block Foundations training. In this section, you'll learn about the details of the V-Block System 720, which is the last of the 4 V-Block system platforms discussed in this course. Upon completion of this training, you'll be able to describe the V-Block System 720 relative to the other V-Block system platforms and identify the typical use cases for this system. You will also be able to identify and compare the V-Block System 720 configurations and identify the basic components that comprise the compute, storage, networking, and virtualization technologies. You'll be able to describe the differences between the segregated network and the unified network configurations of the V-Block System 720. Finally, you'll be able to explain the purpose of the components of the V-Block System 720 management technology.
The V-Block System 720 is the highest capacity V-Block system offering. It is similar in many ways to the capabilities of the V-Block System 320 and V-Block System 340, except, as you will learn in this section, it offers dramatically greater capacity. The V-Block System 720 components are similar to the V-Block System 320 and V-Block System 340, with the most significant difference being in the system storage. For networking, the V-Block System 720 offers both segregated and unified networking, and the V-Block System 720 uses the same UCS compute components. However, the V-Block System 720 uses only the EMC VMAX storage products that you have learned about earlier in the storage section. You will learn here that there are 3 different EMC VMAX products utilized for the storage in V-Block System 720 models. The V-Block System 720 is engineered for the most demanding IT environments. It is an enterprise or service level provider class mission-critical system that supports enterprise workloads and service level agreements that run thousands of virtual machines and virtual desktops. Architecturally designed to be modular, providing flexibility and choice of configurations customizable to suit customers' demanding core data center services and workloads. These include business-critical enterprise resource planning or ERP installations, SAP solutions, customer relationship management CRM applications, demanding databases, messaging, collaboration services, and other mission-critical IT needs. V-Block System 720 delivers a multi-controller, scale-out architecture with consolidation and efficiency for the enterprise. It allows scaling of resources through common and fully redundant building blocks. V-Block System 720 is designed for deployments involving large numbers of virtual machines and users. V-Block System 720 is a modular platform with defined scale points that meet the high performance and availability requirements of an enterprise's business-critical applications. Its features include enterprise-scale performance and data availability. The new V-Block System 720 offers blade servers that are more dense, which means that each server has greater compute power packed into the standard blade. It has an Ethernet-ready unified network topology and a choice of storage arrays. All of this leveraging the latest virtualization platform, providing twice the performance and scale of the previous release. The V-Block System 720 offers extraordinary flexibility. It provides greater configuration choices to meet a broad spectrum of business needs, including consolidation of applications and infrastructure. Organizations managing the most demanding business-critical workloads don't all have the same demands. V-Block System 720 configurations allow these customers to purchase capacity customized to their IT needs. In terms of data protection and mobility, vBlock Systems 720 offer backup and recovery, data replication, business continuity, and workload mobility, all designed to deliver reliable and predictable data protection for vBlock systems. Security and compliance in the vBlock System 720 is engineered, architected, and hardened according to the best practices of each component, including EMC's storage, Cisco's compute and networking, and VMware's virtualization. Systems management. VCE delivers intelligent systems management of vBlock System 720, optimizing services and integrating directly into VMware technologies. VCE also provides an extensible API to leading management tools to protect investments in existing management frameworks. Greater agility. Because the vBlock System 720 is pre-integrated, pre-tested, and validated in the factory, vBlock System can be ordered and delivered within 45 days. Deployment is typically within a week, which includes knowledge transfer. Reducing business risk. vBlock systems are deployed by our 150 vBlock-ready global qualified partners, giving customers a choice of certified professionals that use standardized, proven services. This enables faster time to production for projects and follow-on activities. Streamlined support experience. Like all other vBlock systems, once deployed, VCE support dramatically simplifies the support process, proactively identifying and resolving issues to improve time to resolution and deliver a better support experience. The vBlock System 720 is capable of greater capacity than other vBlock systems. It is designed and engineered to achieve the scale needed for virtual environments that require the most demanding workload and service levels. It is intended for a wide range of mission-critical applications in rapidly growing enterprises. These include core data center services, mixed workloads such as virtual desktop infrastructure, VDI implementations, SAP, Oracle, and Microsoft Exchange. Demanding enterprise resource planning, ERP applications, cloud services, demanding database, business continuity, or disaster recovery services, as well as application development and testing. Like all vBlock systems, the vBlock System 720 models are pre-configured hardware and software platforms. Despite their size and the number of cabinets they can occupy, the vBlock System 720 models are engineered and validated to operate as a single unit. As you can see from the number of cabinets that can constitute a vBlock System 720, physically they can consume more floor space than other vBlock systems. However, realize that this is significantly less space than non-vBlock systems with similar capacity. These systems can contain as many as 48 Cisco UCS chassis filled with Cisco UCS B-Series blade servers, which provide substantially greater compute capacity. Like other vBlock systems, there are 2 IP switches and 2 SAN switches. but the VBlock System 720 offers several alternative switches that can provide greater network capacity. As you already learned, these systems utilize the EMC VMAX storage products, including the VMAX 10K, VMAX 20K, and VMAX 40K, with distinct storage capacities as listed here. The VBlock System 720 comes with the VMware vSphere hypervisor and has a physical amp, which we'll provide more details on later. Let's take a few minutes to address the connectivity within the VBlock System 720. You'll see that there are some similarities with other VBlock systems, but also important differences to understand. We'll start with a look at systems architected with unified networking and block-level storage. Like the VBlock System 320 and VBlock System 340, Cisco B-Series blade servers with blade server chassis and fabric interconnects are used in the VBlock System 720. However, a VBlock System 720 can have up to 5 UCS domains, which means that it can contain many more chassis and pairs of fabric interconnects than is found on other VBlock systems. You'll learn more about Cisco UCS domains and how VBlock System 720 models achieve great capacity in a couple of minutes. For networking switches, the unified configuration uses a Cisco Nexus switch for both LAN and SAN networking, and it offers a higher capacity switch than those offered in other VBlock systems. This higher capacity switch can provide greater network throughput and accommodate both the higher capacity compute and storage found in the VBlock System 720 models. Unlike other VBlock system models, with the EMC VMAX storage, VBlock System 720s can have more than 2 storage processors. The VBlock System 720 with VMAX 10K can have up to 4 storage processors, while the VBlock System 720 with VMAX 20K and VMAX 40K can have as many as 8 storage processors. In VMAX, the storage processors are referred to as engines. These systems can also have many disk array enclosures or DAEs. Note that every unified network switch has 2 connections to every storage processor, and every storage processor is connected to all DAEs. In the VBlock System 720 models with unified network and unified storage, data movers are added to the configuration to perform file server tasks. On the network side, each data mover is attached to the LAN or Ethernet ports on both Cisco Nexus unified switches. And on the storage side, each data mover is connected to every storage processor. To switch from unified network to a segregated network, the 2 unified network switches are replaced with a pair of Cisco Nexus LAN switches and a pair of Cisco MDS SAN switches. The combination of these 4 switches provides more network ports for greater network capacity than is possible with just the 2 unified switches. And finally, the last configuration we'll discuss here is segregated network with block-level storage. As you learned earlier, while file-level storage requires file servers or X-blades, block-level storage does not. Note that for the segregated network, the LAN and SAN switches remain, and block-level storage is configured with no data movers.
You've learned about the basics of the VBlock System 720, so now let's discuss details about its components. We'll start with the compute technology.
We mentioned a moment ago that VBlock System 720 models can contain multiple UCS domains. We haven't talked about domains when discussing other VBlock system models. But think back to the VBlock System 320 and VBlock System 340. Here's what the compute looks like in those systems. There's a pair of fabric interconnects and multiple blade server chassis containing blade servers. This is a single UCS domain. Every UCS domain consists of a pair of fabric interconnects and multiple chassis and blades. For VBlock System 320 and VBlock System 340, they contain one and only one UCS domain, and cannot contain multiple domains. Imagine a VBlock system with two domains, essentially a single VBlock system with the equivalent compute power of two separate VBlock System 320s or VBlock System 340s. Basically, this is what customers can purchase on a single VBlock System 720. Customers can purchase a VBlock System 720 with one domain, or they can purchase a VBlock System 720 with two domains like you see here. And if the purchaser needs more compute capacity, they can add a third UCS domain, or a fourth domain. Actually, a customer can purchase a VBlock System 720 with up to 5 UCS domains. Or they can add up to a total of 5 domains after purchasing a VBlock System 720. That provides a tremendous amount of compute capacity in a single VBlock system. So now you can see, relative to other VBlock systems, just how much capacity a single VBlock System 720 can provide. Just like the VBlock System 320 and VBlock System 340, the VBlock System 720 uses the Cisco B-Series blade servers. Any B-Series blade server offered by VCE can be purchased with these systems. Depending on the blade model, they can contain 2 or 4 multi-core processors, and there are many different RAM configurations available. Blade servers are inserted into slots in the blade server chassis, and these chassis can hold 8 half-width blades, 4 full-width blades, or a combination of the two. 2 fabric extenders in each chassis provides the connectivity between the blade servers and the fabric interconnects. Each chassis has redundant power and cooling components to achieve high availability. Fabric interconnects provide connectivity from each UCS domain in the system compute to the networking and storage components. Fabric interconnects are configured in pairs for high availability, and each pair of fabric interconnects define the boundaries of a single UCS domain. Bare metal rules of other VBlock systems are also applied to the VBlock System 720.
Now let's move on from the compute components to discuss the VBlock System 720 storage technology. As you have already learned, this system uses the EMC VMAX storage products. These will be the focus of this section.
The EMC Symmetrix VMAX family offers high-end storage systems built for the virtualized data center, with consistent and predictable performance and consolidated workloads. The EMC Symmetrix VMAX family can provide several petabytes of storage, utilizing tens to thousands of physical storage drives, and as you learned earlier, can contain from 2 to 8 storage processors. Within VBlock systems, they connect to the compute via fiber channel SAN. EMC VMAX products provide tiered storage using enterprise flash drives, fiber channel, and SATA storage drives. And for customers that require file-level storage, a NAS gateway that serves as the file server is optional. There are 3 different EMC VMAX products utilized in the VBlock System 720 models: the VMAX 10K, VMAX 20K, and VMAX 40K. From the details in this table, you can see the maximum drives and the I/O ports vary depending on the EMC VMAX model. Notice that the drive type options are the same across all EMC VMAX models, and the available RAID configurations include RAID 1+0 for best performance, RAID 5 for the best mix of performance, protection, and economy, and RAID 6 for increased protection with read performance. To accommodate block-level storage, the VBlock System 720 can contain up to 8 engines. System memory of each engine varies depending on the VMAX model, and the fiber channel protocol is used for block-level storage across all VBlock System 720 models. For file-level storage, the number and type of processors contained in each X-blade and the amount of memory vary, as you can see in this table, and the protocols that support file-level storage are the same across all VMAX models.
The last hardware components that we will talk about are the VBlock System 720 network technologies. Here we'll discuss the network switches available in this system.
The Cisco Nexus network switch is available in the VBlock System 720. As in other VBlock system models, this switch serves as a LAN switch in systems with segregated networks and as a unified switch capable of supporting both Ethernet and fiber channel in a unified network. These switches can accommodate both fiber channel ports supporting the VBlock system's SAN as well as Ethernet ports for LAN network traffic. For the VBlock System 720, a higher capacity Cisco network switch is available that is not utilized in other VBlock system models. This higher capacity switch can provide greater network throughput to accommodate both the higher capacity compute and storage found in the VBlock System 720 models. The Cisco MDS SAN switch is only included in systems with segregated networking. This switch only carries network traffic dedicated to the SAN and has only fiber channel ports. It supports connectivity for backup, business continuity using EMC recover point and storage federation requirements. The MDS switches provide line rate ports for non-blocking 8 gigabits per second throughput, and higher capacity switches are available in the VBlock System 720 that is not an option for other VBlock system models. Like other VBlock system models, the VBlock System 720 also comes with the Nexus 1000V virtual network switch. While customers can choose to use other virtual switches, the Nexus 1000V is the only virtual switch that is included in the VCE core support. This virtual switch is used to provide connectivity from virtual machines created and running on the VBlock system to the physical network. Virtual Supervisor Module, or VSM, is the control software on the Cisco Nexus 1000V virtual switch. It runs on a virtual machine and is based on Cisco NXOS software. Virtual Ethernet Module, or VEM, is part of the Cisco Nexus 1000V that actually switches data traffic. The switch is the standard virtual switch in the VBlock systems, replacing the switch that comes with vSphere.
There are just 2 topics left. You'll learn about the VBlock System 720 virtualization now. Then we'll finish this section of the training with a discussion about system management.
The VBlock System 720 comes with a number of ESXi host licenses. These hypervisors are deployed in cluster configurations. VMware vSphere is the virtualization platform that provides the foundation for the private cloud. These hypervisors are usually deployed in a cluster configuration to enable pooling of resources. As you learned earlier, ESXi hosts in a cluster share LUNs. This simplifies management tasks and makes it easy to move a virtual machine from one physical server to another while the virtual machine is running. VMware vCenter Server comes installed on the VBlock System 720 and provides functionality for cloning or copying virtual machines, as well as for creating templates that can be used to create duplicate virtual machines. It includes both VMware vMotion and VMware Storage vMotion. Click the links if you want to learn more about these. VBlock systems come configured with DRS and VMware vSphere HA clusters. VMware Update Manager provides information and tasks for vCenter upgrades and patch management. The SQL Server is the database backend for vCenter. It runs on a separate virtual machine from the vCenter for performance and portability.
Let's turn our attention to the last topic, VBlock System 720 management. We'll talk about both the AMP and the management software tools used in the VBlock System 720.
All VBlock 720 models require a Physical Advanced Management Pod, AMP. As you learned earlier, these are used to manage the VBlock system with dedicated hardware that separates management traffic from user workload traffic. The 2 configurations that you learned about, the mini-AMP and the HA AMP, are both available on the VBlock System 720. Remember, as we discussed earlier, in the near future, the 2 AMP configurations will be replaced by a new VBlock system management infrastructure, providing a broader range of options with greater flexibility in customization to the customer's needs. The servers of the AMP are configured with internal storage. The HA AMP also includes VNXE 3150 for shared storage for backup purposes. As we discussed earlier, a key differentiator to the VCE vBlock system over other cloud appliances and the traditional data center model is the Strategic Advanced Management Pod, AMP. The vBlock System 720 has a physical AMP. The management software that is installed on the vBlock System 720 AMP is listed here. Take a moment to review this list and click on any of these links for more information.
This is a learning check that provides an opportunity for you to assess your progress. Each question...
Well done! You've completed the Introduction to the vBlock System 720. In this section, you learned about some of the details of the system, including how it compares to other vBlock system platforms, its use cases, and about the vBlock System 720 configurations. You also learned about its compute, storage, network, and virtualization technologies. And finally, you learned about the differences between the segregated and unified network configurations and about the vBlock System 720 management technology.